Action. Right, question 7. Says, sketch the curve y equals x squared 3 minus x, stating the coordinates of the points of intersection with the axes. Alright, we know, this is, to start with, it's a cubic curve, isn't it? If we multiplied it out, so let's do a little bit of kind of digging around with this. If we multiplied it out, it would have a minus x cubed term. It would be 3x squared minus x cubed. The minus x cubed term means that we're looking for a curve that is kind of positive at the negative side of x, and as x gets bigger it's getting more negative. We want a curve that is doing that kind of shape, don't we? That's a negative x cubed curve. It's an x cubed curve, so we need that kind of shape, not a quadratic curve at all. And we know that if we've got a squared term, that's one of these repeated roots. So this is going to cross at 0 and 3. They are the roots. It's going to cross the y-axis at 0 as well. If you put, if y was equal to, so if x is equal to 0, you'd have 0 times 3, wouldn't you? So that's 0. And we've got the repeated root when x is 0. That one occurs twice. So I think from all of that we're getting a curve that is going to do that kind of shape. We've got a repeated root at 0. We've got it crossing at +3 as the other point. And that's it. And that's going to get us, they gave 3 marks for that. We're getting 1 mark for a negative x cubed cubic graph. We're getting another mark for it meeting only at 0, 0. And we're getting the 3rd mark for the double root at 0, 0 and the single root at +3 on the x-axis. Okay, that's it. The curve is translated by 2 units in the positive x direction parallel to the x-axis. State the equation of the curve after it has been translated. The curve is translated 2 units in the positive direction parallel to the x-axis. So that means, well, let's think about this now. That means that that double root is now going to be at 2 instead of at 0. So that double root, that was x squared, is now going to be x minus 2 squared. That will give us the double root. And the other root, which was at 3 minus x, is 2 units further over, so that's now going to be at 5 minus x. I think that is probably the most straightforward way of thinking about how to do that. You could have thought about it in a few other ways. You could have thought we're replacing x with x minus 2. It's that transformation of graphs. So you could have done it from that one there and thought about it as being 3 times x minus 2 squared minus x minus 2 cubed. You could have thought about it that way. You see, I've replaced x with x minus 2, thinking about the translation-y stuff. And there we have it. Okay? Remember, when it says state an equation of a curve, you have to have y equals as your equation of the curve. Must have y equals in there. Okay, just describe fully a transformation that transforms the curve y equals x squared times 3 minus x, so the curve we're dealing with, to a half x squared 3 minus x. So we're looking at what has happened to this graph. It's an afterwards transformation, is it? It's not that something has happened to x, because it's not that x has been replaced with something, because that x inside the bracket hasn't changed at all. It's exactly the same. It's what you've done if you've taken the original graph and you've multiplied it, instead of calling the original graph f of x, you've multiplied it so it becomes a half f of x. Now our poster says that that kind of transformation is a stretch. So there we have one mark for the word stretch. And if we're describing a stretch, we need to give the scale factor and the direction. So it's a stretch, scale factor a half, because we multiplied it by a half, And it's in the y direction, so it's parallel to the y-axis. Okay, and I did have quite a few people give the wrong direction. They got that bit on right, but then said parallel to the x-axis. So the stretch is parallel to the y-axis. You can't say a stretch in the y-axis, because that's ambiguous, whether that means horizontal or vertical. You can say in the positive y direction. That's okay to say that. But parallel to the y-axis is probably the best way of saying it. There we go. I think we may have some disagreement on some marks here. All right. See what people think. That's math.